Dear friends, welcome to Bond with RK Chemistry YouTube channel. In this video, I am going to explain the multiple choice questions from 16 to 30 which are appeared in JAM 2021 chemistry question paper. Let's take question number 16. For alpha greater than 0, the value of the integral minus infinity to plus infinity x e power of minus alpha x squared dx is. Let's take this term as y is equal to alpha x squared. When you differentiate y, dy is equal to d alpha x squared. Alpha is constant, so you will get dx squared. And this one is alpha into 2x dx. And here x dx is equal to, that implies x dx is equal to dy by 2 alpha. So in place of x dx, you can write dy 2 alpha. In place of alpha x squared, we can write e power of, now you can write y. So this integral is equal to x dx is alpha 1 by 2 alpha dy, and this one is e power of minus y and dy. So 1 by 2 alpha is constant, so integral e power of minus y dy. Exponential integral, if you take, it will be 1 by 2 alpha into minus 1 e power of minus y. So it can be written as the integral will be 1 by 2 alpha minus 1 by 2 alpha e power of minus alpha x squared. Y is equal to alpha x squared. So when you put limits, these are the limits minus infinity and plus infinity, we will get minus 1 by 2 alpha e power of minus alpha infinity square plus infinity square, it will be infinity minus e power of minus alpha minus infinity square, obviously infinity. So you will get e power of minus alpha infinity minus e power of minus alpha infinity, it will be 0. So the whole thing will be 0. So what is the answer? Third one is the correct option. The correct statement regarding the molecules BF3 and CH4 is microwave active and infrared active. When you irradiate microwave, there is a rotation of molecule. There is a rotation, microwaves. When you irradiate IR, there is a vibration. The molecules which have permanent dipole moment means mu naught is equal to 0. These are active, microwave active. And when there is a change in dipole moment, change in mu, when there is a change in mu, when there is irradiation of infrared, then the molecule is infrared active. So for mu is equal to 0, if mu is equal to 0, then this one microwave inactive. Microwave inactive. If you take IR, only diatomic molecules, except diatomic molecules, diatomic symmetric such as H2, O2, N2, or X2, these are inactive. Why these are inactive? Here, mu is equal to 0 and there is no change in mu. Delta mu is equal to 0. But if you take any other molecules, so let's take CO2, CH4, or if you take any other molecules, BF3, okay, these are symmetric molecules. In this case, mu is equal to 0, but delta mu is not is equal to 0. So these are microwave inactive. These are microwave inactive, but these are IR active. When there is a vibration, there is a change in dipole moment. In some modes, there is a change in dipole moment. There is a dipole moment. So these are IR active. Let's take the options. So CH4 is microwave active. Here mu is equal to 0, inactive. Infrared inactive. Good. So this one is wrong. BF3 is microwave active. This one also wrong. And both BF3 and CH4 are microwave active. This one also wrong. Both BF3 and CH4 are infrared active. This one is correct. The reaction that produces the following as a major product is the first reaction. This one is okay, when you trade this one. This one is Julia-Litho reaction, olefination reaction. This one is Julia-Litho olefination reaction. In Julia-Litho olefination reaction, we get we will get G configuration. The olefin, the C double bond C, the configuration at the C double bond C is E. Lindlar's catalyst, we know that there is a syn addition of hydrogens takes place. Syn addition takes place. So here we will get the Z configuration. Here we have E configuration at the double bond. In this case also there is a formation of double bond. In this case also there is a formation of double bond. In this case also there is a formation of double bond. But here you will get G, here you will get Z. This one is Wittig reaction. Wittig reaction. The reagent is unstable. The ylide is unstable. So it can form Z, not E. The stable ylides form E. The unstable ylides form Z. So here you will get Z, not E. So in this case also you will not get, in this case you will not get E. In this case you will not get E. In this case you will get E. So what is the correct option? First one is the correct option. The major product formed in the following reaction is here NaBH4. This one is hydride donor. This hydride attacks on the this keto group from back side to the plane. Since the methyl group on adjacent carbon is about to the plane, the hydride will attack back side to the plane. So here you will get this one is methyl group and this is double bond O. Here there is an attack of hydride ion from back side. So you will get back side there is a hydrogen and above the plane, below the plane hydrogen, above the plane O minus. So you will get OH minus above the plane and H minus below the plane. So which one is the correct option? Fourth one is the correct option. Here there is no change in configuration at this carbon center. According to the crystal field theory, Diels transitions observed in TiH2O6 3 plus is. Okay, there are two rules, a spin rule and orbital rule. Okay, spin rule, selection rules if you take, there should delta S should be 0. For orbital's rule, delta L should be plus or minus 1. Then only this one is allowed. If delta S is equal to 0, allowed. Delta L is equal to plus or minus 1, allowed. The orbital rule, it is also called as Lambert rule. Okay, according to this rule, when there is a change in angular moment, orbital angular moment, then there is a the transition is allowed. When delta L is equal to 0, suppose delta L is equal to 0, this one is forbidden. If you take DD transitions, there is a transition between D orbitals. So there is no change in L value. Delta L is equal to 0. According to Lambert rule, this one is forbidden. In titanium 3 plus, what is the electronic configuration of titanium 3 plus? This one is titanium is, the electronic configuration 3d2, 4s2, and the titanium 3 plus G1 electronic configuration. So in titanium 3 plus, this is the electron. When there is a transition between these two levels, there is no change in spin. So here delta S is equal to 0. So this one is spin allowed. So this one is laboratory forbidden and spin allowed. The products P, Q, R, and S formed in the following reactions are. What are the products P, Q, R, and S formed in the following reactions are? So let's take this one. When you treat with H plus, HBr, there is a protonation, OH2 plus, here there is a double bond. In the next step, there is attack of Br minus. The Br minus can attack here SN2 type or SN2 dash type. So you will get, in case of SN2, you will get Br here and double bond here. SN2 dash type, this is a product. This one is major and this one is minor. Okay, when you treat with Cn minus, CuCN, here there is an attack of Cn, here there is an attack of Cn, or here there is attack of Cn. When there is attack of Cn at this position, you will get this one Cn minor plus, and here when there is attack Cn, this is the double bond. So this one is major, and this one is minor. So when you treat with concentrated HCl, there is a hydrolysis. Respective carboxylic acids you will get. So this one is minus COOH, minor COOH, and this one is major COOH. So P is this one and Q is this one. In case of this one also, you will get similar products. So what is the correct option? P is equal to R is equal to this one. Q is equal to S is equal to this one. Third one is the correct option. Monochromatic X-rays having energy 2.8 into 10 to the power of minus 15 joules. This one is 2.8 into 10 to the power of minus 15 joules. Diffracted, first order, from 200 plane of a cubic crystal, an angle of 8.5 degrees. 5 degrees, the length of unit cell in angstrom of the crystal. Okay, here the parameters are given. First, you have to find out the lambda value, X-ray of lambda value. We know the equation U is equal to H nu. This one is Sc by lambda. So lambda is equal to Sc by nu, Sc by G. So when you substitute these values, 6.626 into 10 to the power of minus 34, and C is 3 into 10 to the power of 8 meters second inverse, and G is given 2.8 into 10 to the power of minus 15. When you simplify lambda, you will get around 7 into 10 to the power of minus 11 meters. It can be written as 0.71 angstroms. So lambda is 0.71 angstroms. From Bragg's equation, n lambda is equal to 2d sine theta. Here n is equal to 1. We know the lambda value. And what is d? Here d square, d is equal to a root over h square plus k square plus l square for cubic system. So d is equal to a by, here HKL values are given 200. So this one is 2 square plus 0 plus 0 plus 0 root 4. It will be a by 2. D is equal to a by 2. So and lambda, we have to find out a value. So here lambda is equal to 2 into a by 2 sine theta. So a is equal to, there is a cancellation of 2, a is equal to lambda by sine theta. Okay, lambda value 0.71 angstroms, 0.71 angstroms, and sine theta, sine 8.5 degrees. Sine 8.5 degrees will be 0.71 by 0.147. You will get around 4.8 angstroms. So third one is the correct option. The volume correction factor for a non-ideal gas, that is real gas, in terms of critical pressure, critical molar volume, critical temperature, and the gas constant RS. So we know the equations Vc is equal to 3b and Tc Vc by Tc is equal to 3 by 8 R. So this is the relation. In place of Vc you can write 3b. So Pc 3b by Tc is equal to 3 by 8 R. So there is a cancellation of 3 and 3. So B is equal to RTC, RTC 8 PC. So RTC by 8 PC. Half-life of a chemical reaction varies with the initial concentrations of reactant as given below. Initial concentrations are given and half-life times are given. We know the relation between initial concentration and half-life time. Half-life time is indirectly proportional to a power of n minus 1. N is the order. Suppose half-life times, two different half-life times, if you take T2 by T1 is equal to A1 by A2 power of n minus 1. Let's take two different half-life times. Let's take 360 and 450. This one is T1, let's take. This one is T2. This one is A1. This one is A2. So T2 by T1, 450 by 360 is equal to A1 by A2. A1 is 5 into 10 to the power of minus 2 by 4 power of n minus 1. There is a cancellation of 10 to the power of minus 2 times. So here you will get 9 fours and 9 fives. So 5 by 4 is equal to 5 by 4 n minus 1. It means the n minus 1 is equal to n minus 1 is equal to 1. When n minus 1 is equal to 1, then 5 by 4 is equal to 5 by 4. So n is equal to 2. It's a second order reaction. The major product formed in the following reaction sequence is, what is the major product? Okay, let's take this one. In presence of ethoxide, there is a removal of protons, so this one becomes a carbanion. This ethoxide abstract proton. This one is active nucleon compound, so there is abstraction of proton from abstraction of proton from this active nucleon group. So next case, this carbanion attacks. This carbanion attacks on this carbon, and there is a nucleophilic addition reaction. So you will get, and this one is OH, and here you will get C double bond O, OET, and C double bond O, OET. When you treat with amines, CH3 twice NH, there is a formation of amide. So here there is no change. This one, OH, this one will become NCH3 twice, and this one is ester, OET. Next place, there is a reduction. Both amides and esters both can be reduced by lithium aluminum hydride. So there is a formation of this one, OH. This one will become OH, and this one will become OH, CH2, OH, and this one will become CH2, CH2 and CH3 twice. When you treat with HCHO, there is a formation of acetone. So here C double bond O H, there is a removal of water molecules. So there is a formation of acetone. So finally, we will get this compound NCH3, CH3, and here there is a formation of acetone. Second one is the correct option. The major product formed in the following reaction is, what is the major product? This is the diene, and this one is the dienophile. This is the thermal condition, so it's a Diels-Alder reaction, 4n plus 2 bicycloaddition reaction. We know that the reactivity of dienophile methyl is greater than methoxy. So here you have double bond which is attached with methyl group. Here double bond is attached with methoxy. Cycloaddition takes place at this double bond, not at this double bond. And also it's a stereospecific reaction, and here the both Me and H should be above the plane. So addition takes place at this one, this double bond. So you will get Me, H, and both Me and H should be above the plane when this diene approaches below the plane of dienophile. So this is the correct option. In the following reaction, compound Q is. Here let's take this one. Here you have hydrogen both above the plane and below the plane. You have below the plane and hydrogen. And here also below the plane there is a hydrogen. In elimination reaction there should be anti-periplenarity condition. So here there is a possibility of elimination of this hydrogen and chlorine, this hydrogen and this chlorine. So you will get two. Here you will get two products. This double bond, and also there is a possibility of this double bond. Suppose if you take this one, here above the plane there is a hydrogen. Here you have two hydrogens, one is above, one is below. In this case also you will get double bond here. Along with this product you will get a double bond here. So this one cannot form only this product, this one also cannot form. Suppose if you take this one, below the plane there is a hydrogen. This hydrogen and chlorine are not in anti-periplanar condition. Both are in same plane. So there is no removal of this hydrogen and the chlorine. So here there is a removal of hydrogen. So you will get only one product. This product you will get. Suppose if you take this one, here this hydrogen, let's take this one is above the plane. So here also there is no elimination. So you will get only elimination from this hydrogen, this above the hydrogen, and below there is a hydrogen. So below hydrogen will be removed. So you will get alkene type of product. There is elimination. Along with elimination, there is a possibility of substitution. Here, OUT minus can remove Cl minus and there is a formation of substituted product. But in this case, why there is no substitution? Here there is a bulky group adjacent to the leaving group. So here there is no substitution. No substitution here. But here there is a substitution. So here you will get eliminated product and also substituted product. So third one is the correct option. The decreasing order of C double bond C bond length in the following complexes is the platinum complexes are given. This one is chlorine, chlorine, and chlorine, and here there is a double bond, C double bond C. Here the C double bond C ligand can act as a sigma donor and pi acceptor. As the pi accepting nature increases, the C double bond character, C double bond C character increases. So bond length decreases. This one depends on the substrates. Suppose if the substrates are small in size, the alkene in the plane of complex. So there is a more back donation or pi back donation. So there is a more double bond character. So there is a less bond length. When you substitute more bulky groups, there is a less pi back donation. So there is a less C double bond C character. There is a more bond length. So as a size of substance increases, bond length increases. So in case you have hydrogens, in case you have 4 cyano groups, 2 fluorines, 2 hydrogens, 4 fluorines. Cyano group is a bulkier group. So second one has high bond length, and the next one 4 fluoro groups. So fourth one, and next one is third one, and the least one is first one. So this is the order: second, fourth, third, and one. This is the correct option. Hybridization of the central atoms in I3 minus ClF3 and SF4 respectively are. What is the hybridization? Here all the I3 minus ClF3 and the SF4, all these have sp3d hybridization. This one is sp3d, and this one is sp3d, and this one also sp3d hybridization. So second one is the correct option. The correct conclusions are for the metalloenzymes given in column 1 with their catalytic reactions in column 2 is. What is the correct one? Cytochrome P450. What is the nature of cytochrome 450? It's acting as hydroxylation or epoxidation. So there is a insertion of hydroxy group. This can insert hydroxy group. RH can be converted into ROH. So what is the nature of this one? This cytochrome P450, this one converts RH, alkanes, into alcohols. Catalase, this one decomposes hydrogen peroxide into water and oxygen. Galactose oxidase, this galactose oxidase converts primary alcohol RCH2OH in glucose molecules into RC double bond OH. So primary alcohol will be converted into aldehyde. This is galactose oxidase. Cytochrome C oxidase, this one converts water into H2. So this one is this one. So what is the correct option? First one is N, and the second one is K, 1N, second one is K, third one is L, fourth one is M. So fourth one is the correct option. Thank you. In coming video, I will explain multiple selection questions. Thank you.